In this video, we're going to be going over graphs of functions. Now, there are parent functions that we're going to be looking at. And you kind of already know some of these, but what I'm going to do is dive down a little bit deeper into their characteristics. So the first function that we're going to be looking at would be the linear function. All right, and that's going to have the form f of x equals mx plus b. And remember, we can think of this f of x as y, and then the x inside of the function as just the variable x itself. In other words, the input and outputs respectively. Okay? So let me get rid of these real quick. There we go. Now, the linear function is going to look like this. So we have our xy, and it's straight up a line. Now, m, we know is the slope. Okay? B is going to be the y component of the y-intercept. And this is probably the most important part of the characteristics. This is why I'm going over this. Our domain is going to be negative infinity to infinity, and our range is going to be negative infinity to infinity as well. Now, remember, domain, input, independent variables. Range, output, dependent variables or dependent values. Okay? So the idea behind, well, how do you read domain and range when you look at a function on a graph? The best way to kind of explain this is if you were walking on the x-axis. All right, so there's me walking on the x-axis. Now, if I move to the left or to the right, notice I'm on the x-axis. That's left and right movement. Those values would be my domain. In other words, if I can look up or down and still see the function, then I know I'm still within the domain of this. Now remember, like I said, domain, x values, range, y values. So for domain, you're walking on the x-axis. The same applies for the range, except on the range, now you're walking on the y-axis. So how low does your graph go and how high does your graph go? So linear functions are defined everywhere, meaning the domain and range are both negative infinity to positive infinity. Okay? Now, the next function we're going to look at is the constant function. The constant function has the form f of x equals b. And this is nothing more than a horizontal line. All right? Some important characteristics. Our domain is going to be negative infinity to infinity. However, our range is going to be the value of b only. And how did I get that? Well, if you look right here on the y-axis, that is going to be your y-intercept. Okay? So, since the y-intercept, or better yet, let me say it like this. Since you have a horizontal line and it goes through the y-intercept, all of your y values are going to be the same. And remember, range specifically deals with y values. Okay? Now, the next function we're going to look at, the third one, is what we call the identity function. And that's when we have f of x equals x. And that looks like this. It goes right through the origin, and no matter what, every single one of these values is going to be the exact same. So like, for example, the first ordered pair, and I'll draw like a little arrow, that's going to be 1, 1. The next ordered pair is 2, 2. All the way down here, well, that could be -3, -3. In other words, the x and the y are always the same exact thing. Our domain, oh, sorry, there goes my Apple Watch. Sorry about that. Our domain, negative infinity to infinity. Our range, negative infinity to infinity. Okay? So the next one is going to be the square function. This has the form f of x equals x to the second. And we call this shape a parabola. And that's going to look like this. All right. So we call this a parabola. Our domain is going to be negative infinity to infinity. Our range is going to be 0 to infinity. And I'm including 0. That's why I use the bracket. Very important for us. That bracket means we are including 0. Now, I think this is a really good break for a second, just to reiterate what's happening. For the domain, remember, we're thinking x values. Okay? So if I walk along the x-axis to the left or to the right, if I can always see my square function either above or below me, that means it's defined there. Okay? Now, if you walk along the y-axis for the range, so remember, range are y values. Now notice the lowest point I can get on this function is the vertex, which is ironically at the origin of 0, 0. And look at that y value. Y equals 0. So that's the lowest I can get. The highest I can get, in other words, if I walk up the y-axis, the highest I can get is going to be infinity because the square function goes on forever. And that's exactly how we read functions for domain and range. And we got some more coming up. We have the cube function. So this is going to be number 5. We have the cube function. That has the form f of x equals x to the third. And it looks very similar to the square function. It's just on one side, in the positive x direction, it goes up, and the negative x direction, it goes down. So our domain is going to be negative infinity to infinity. And our range, negative infinity to infinity. The next one, I know there's a bunch. The next one, number 6, well, that is called the square root function. Okay, and that looks like this. F of x equals the square root of x. All right. And this, we got to be careful with this one because our domain is going to be from 0 to infinity. And our range is also going to be 0 to infinity. All right. Finally, number 7, we have the absolute value function. That's going to be f of x equals the absolute value of x. And this kind of looks like a parabola, except it's very specific. It's like this letter V. In fact, at the origin, we call that a cusp. That's what that's called. And if you happen to take like Calc 1, you'll learn about that later in Calc 1. But our domain is going to be negative infinity to infinity. And our range is going to be 0 inclusively to infinity. All right. So now what I'm going to do is I'm going to pull some examples out of the book, and I'm going to show you how we read information from a graph of a function. All right. So just give me a second here. I'm going to pause the video and open up the book and copy and paste some pictures. All right. So here's an example here from our text. And we're going to do exactly what it says. It says use the information of the function to find its domain and range. Write the domain and range in interval notation. All right. So the first thing we're going to do is we're going to identify the domain. Now remember, domain are going to be x values. So the idea behind this is how far to the right can I go if I'm walking on this x-axis? How far to the left and how far to the right? That's it. Now, they did something very nice in this example here. All right, if you look at it in red, they're showing you, hey, here's where the domain is. Okay, you go from this ordered pair, which is going to be -5, comma, -4, all the way over to this ordered pair right here. That's the furthest to the right ordered pair, and that's going to be 1, comma, 2. And since they are solid dots, and we know and we know domains are x values, then our domain is going to be -5 all the way up to 1 with brackets around it. And that's it. That's what the domain tells me. How far to the left, how far to the right. Now, oh, I guess I should have left that there. Now for our range, and I'll write this in blue. So our range, now we're walking on this y-axis. So how low can I go? Well, the lowest ordered pair is going to be -5, comma, -4. That's the lowest. Because remember, it goes all the way, like, you know what I mean? Like this is like the bottom of your function and this is like the top. So you're looking for the lowest y value. And that's going to be -4. And since the ordered pair is solid, we can include -4. And then how high does this graph or how high does this function go? Well, it goes all the way up to +2. And that's it. That's all this is how we read information from a graph. All right, let's try a couple more here. Okay, this next one is going to be probably the one that I get the most questions about on the homework. That's going to be this right here. All right. So notice here we have a function. In fact, there are tons of functions that exist, even more than the ones we went over. And this one happens to be f of x equals the cosine of x. That's what this one is, okay? But you don't have to know its name, and that's fine. All we're worried about are answering the questions to the left. So we're going to do this one step at a time. So here's part A. And part A says, hey, what is f of 0? All right? In other words, when x equals 0, what is your output? Well, that is going to be this ordered pair right here because that's where x equals 0. And in this case, that is the ordered pair 0, 1. So when, what is f of 0? F of 0 equals 1. And that's it. So that's part A. Let me, I'll erase this. Part B, now they're asking, what is f of pi? Well, once again, you're going to go on the x-axis to where f of pi would be, or x equals pi, and that's going to be right here. And that's the ordered pair down there. Okay, so I guess what I can do here is just put pi for us, so we can easily see that. All right, so what is that ordered pair? Well, that's going to be pi, comma, -1. So f of pi is equal to -1. Now, same thing. They're asking us for part C, what's f of -pi? Well, f of -pi is over here. So that is going to be, and I'll write that here, -pi. So that's going to be -pi, comma, -1. That's that ordered pair. So f of -pi equals -1 as well. All right, now part D. Part D ask us to find the values for x in, and remember, this is an interval. So find the values for x in -pi or -2 pi to pi when f of x equals 0. So what they're asking us here is this. They're saying, okay, let me erase some of this stuff on our graph. I really want to highlight this. They're saying, okay, from this far left side of the graph all the way to this far right side of the graph, tell me when y equals 0. Now we know that when y equals 0, and we're looking at ordered pairs, these are going to be x-intercepts, because the definition of the x-intercept is it is a point on the graph when y equals 0. All right. So where does y equal 0? Well, if I zoom in here for us, y equals 0 here, 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 and here. So there are 4 x values for when f of x equals 0. So I'm going to zoom back out. So we have 4 x values when f of x equals 0. Okay? And I'm just going to go ahead and I'm going to list them below. So the first one is going to be negative 3 over 2 pi, comma. Next one is going to be negative 1/2 pi, comma. Then we have 1/2 pi, comma. And then we have 3 over 2 pi. All right? And yes, you would type this in exactly the way this would look like within WebAssign. All right? Because you're going to have questions like this in WebAssign as well. All right? So let me go ahead and erase some stuff here. Now, part E. Part E says, hey, find the x-intercepts. Well, if you look at part D, you found the values of x for when f of x equals 0. We know just by looking at our graph that it just happens to be all of the x-intercepts. So this answer, part E, is the same exact answer as part D. So negative 3 over 2 pi, comma, negative 1/2 pi, comma, 1/2 pi, comma, 3 over 2 pi. All right, so there's part E. Part F. Part F says, hey, find the y-intercepts. Now, that is where this graph will cross the y-axis, and that only occurs at one specific value. There it is in red, and that's going to be the point 0, 1. So what we would just write here would be 0, 1 in WebAssign. You're just going to type in the number 1, all right? Because it's going to say like y equals, I think, in WebAssign, all right? Just be careful. Make sure you read the directions. Finally, part G, they're asking us for the domain and write it in interval notation. So let me erase some stuff here. So if we look at our graph, notice that we have these arrows on the far left and far right sides, and they mean it just keeps going. So in this case, our domain is going to be negative infinity to positive infinity because they keep going. That's what the arrows represent. Okay? Now, for part H, and remember, H is going to be the range. And we have to remember that range is how high does the graph get and how low does the graph get. So what I'm going to do here is I'm going to zoom in real fast for us. And if you look, give me a second. There we go. If we look here, our graph is bounded in between those two lines. All right. It never goes above or below those two blue lines that I wrote. So what are those y values? Well, the smallest y value is going to be negative 1. And then the highest y value is going to be positive 1. So our range is going to be negative 1 to positive 1. And I knew to use the brackets because I can draw a solid circle or a solid dot for those values right there. So I can include them. All right. And that'll be it for this video. All right. So I hope this helped. And domain and range, very straightforward. You just got to read it. And the hardest part is kind of like separating, okay, domain, strictly X values, range, strictly Y values. And that's it. So have a good one.